Okay, in question 6 we've got a polynomial function p of x, and we've got to use the factor theorem to show that this is a factor. Use the factor theorem means that you're going to get no marks for doing division or the grid method. Okay, you have to substitute a correct magic value of x that you deduce from that into p of x, shove it in there, get a particular answer out, and then comment on it. If you don't draw the conclusion and end up by saying therefore x plus 1 is a factor of p of x, you won't get the second mark. Then, with that as our starting point, we're going to express this as a product of three linear factors. Now we need the grid method. X plus 1 is one factor. Decide what you need across the top that will end up with a grid that multiplies out to this. And once you've got it like that, you've got x plus 1 times a quadratic bracket, and then you factorise your quadratic bracket, so you end up with the product of three linear factors, just like what they tell you to. Then, in part B, we've got a lovely sketch graph of the curve. So the curve, it says, cuts the x-axis at the point A, and these other 2 points here. The coordinates of the point A, well, they're really trying to help you here. You've got the thing factorised into linear factors. Intersections with the x-axis are when y equals 0, and this thing will equal 0 when your product of your three factors equals 0, and so that gives you three possibilities leading to three x values. Two of them are just given to you on a plate, so you've just got to work out the x coordinate of A, and that is the marks you need. That's what you need for the 1 mark in B.E1. Then we've got to do a definite integral. Tons of marks for this, okay? They are very generous the first time they ask you to integrate stuff. Okay, so we've got three terms. Use your recipe from chapter 7, okay, to get three terms. It will be in square brackets, okay, with the limits on. Once you've got the three terms, you don't need plus c for a definite integral, but you do need to substitute in your limits and do a subtraction and get an answer. And then you stop, okay? Because what you're expecting to happen promptly does. Hence, find the area of this shaded region. Now the diagram is drawn for you and the region's in a particular place, which means that you were all along expecting a particular kind of answer here, which you shouldn't have tampered with yet, because this 1 mark is for showing that you know how to adapt that answer to get the answer for the area. Okay? If you didn't get an answer of the required kind here, okay, and you now realise you didn't, what you need to do is check your working, and whatever you do, make sure that even if you've got a wrong answer here, it's at the correct type that you can get this mark for adjusting it correctly to get the area of the shaded region. Moving on, we've got to find the gradient of this curve now. This is a total re-entry point, okay? We've had other re-entry points in the question. For this one here, we just start all over again by finding a gradient. How do we find gradient of a curve? Answer is dy by dx. So 3 more easy marks for using your chapter 5 rule for differentiation. And then in chapter 6 you've got plenty of examples of how to work out the equation of a normal. It's a straight line, so we need a point and we need a gradient. Okay, where's your point coming from? Oh, point B. Where's your gradient coming from? Well, we've got the gradient of the curve at any given x value. Substitute something in, but remember the equation of the normal might need an adjustment to the x value you get. Anyhow, you've got examples in chapter 6, so jolly well go and look them up.